Another example about friction. Here we have example 2. Gwen exerts a 36 Newton horizontal force as she pulls a 52 Newton sled across a cement sidewalk at a constant speed. What is the coefficient of kinetic friction between the sidewalk and sled? Alright, so we have this number. So 36 Newton. Gwen exerts this force. So this is the applied force, F applied, equal 36. As she pulls a 52 Newton sled, the sled weighs 52 Newton. So this is the weight of the sled, or in other words, it's the force of gravity, Fg. Across a cement sidewalk at a constant speed. Here, this term here actually is very important. The question is to find, or what is the coefficient of kinetic friction between the sidewalk and the sled. So I have to find mu k. Okay. So to find mu k, we have to use this equation. Mu k equal to fk over fn. We need to know fk, we need to know fn, which we don't know anything about them according to the given that we have. So following the tips that I gave you before, tip number 1 is to draw a free body diagram. So I have a sled that is pulled on a cement sidewalk. Let's say this is the sidewalk. This is the sled here. Okay. And then the force is acting first. This is the sidewalk. This is the sled. Now I draw the forces acting on the sled. Force of gravity, G, which is 52 Newton. We have the normal force, Fn. Applied force, or F push, F applied, and friction, kinetic friction, F. Here it's kinetic friction because the sled is moving. So this is step number 1. Step number 2, we apply Newton's second law. So Newton's second law, F net is equal to m times a. So here the object is moving, so you may think that there is acceleration, but because the question is saying that the sled is pulled at a constant speed, then of course constant speed in a horizontal direction, along a horizontal direction, so we can say it's constant velocity. Constant velocity means zero acceleration. There is no acceleration, so therefore F net equals to m equals to 0. M times 0 is 0. Also, we said here that F net, we said before, that F net is the sum of forces along the x-axis, or along the horizontal. This is the horizontal direction. So the forces are F applied and Fk, and because they are in opposite directions, so they are subtracted. So here, F net is F applied minus Fk is equal to 0. So Fk is equal to F applied equal to 36 Newton. I have that. So this is the first unknown. I still have to find another one, which is Fn, in order to get Newton. So how can we get Fn? Yes, from the y direction, or the horizontal, the vertical, along the vertical, the y-axis, I can say that Fn is equal to Fg. Here I don't need to replace Fg by m times g because Fg is already given, 52 Newton, it's there. So just replace it by 52 Newton. So now I have everything. To find mu k. So mu k is equal to 36 divided by 52. Mu k is equal to, give me 1 second, I calculate it. 36 divided by 52, it's 0.69 million. This is mu k. Alright? So here, constant speed actually is the key to solve a problem. If you couldn't notice that constant speed gives me zero acceleration, then we would have a problem here with A. What can we do with A? So we'll have more than two unknowns. Okay, but since they mentioned here constant speed, constant velocity, then I can replace A by 0. Third example. Example 3. We have a 1.4 kilogram block slides across a rough surface such that it slows down with an acceleration of 1.25 meter per second square. What is the coefficient of kinetic friction between the block and the surface? So I have to find mu k, coefficient of kinetic friction. This is the unknown. Now let's see what we have given here. We have this here. This is mass 1.4 kg. Slides across. Slides. What does it mean that the block is sliding? Sliding means it's moving under the action of the force of friction only. There is no force of push. Or if you want, the block is given a force of push to make it moving or to put it in motion. Okay, then this force is seized or stopped. So as the block slides on the surface, the force of push is not there. The only force acting on it is the force of friction. This force of friction is what is causing the slowing down of the blocks. Is what is nice. So the acceleration here is 1.25 meter per second square. As it slows down, this means that acceleration is negative 1.25 meter per second square. Okay, so this minus sign here, why it's there? Because the box is slowing down. If it's speeding up, then it will be plus. Okay, so 1.4 mass slides across a rough surface, slows down with an acceleration. What is the coefficient of kinetic friction between the block and the surface? So this is the given that I have. I have to find the mu k. To find mu k, we need to know fk and fn. So first, again, we draw the free body diagram. So this is the rough surface. Let's say this is the rough surface, and this is the block. Okay, the force acting on the block, Fg, Fn, there is no force of push, but there is force of friction, Fk. So then Newton's second law, F net equals MA. Here A is not equal to 0, actually it's here given. The M is given. F net here along the horizontal direction. Always remember that F net is taken along the direction of motion. So the motion is taking place along this direction. So what's F net here? As you see here that the only force acting on the block is Fk. But Fk is in a direction opposite to that of the motion. And the direction of motion is my positive direction. So F net would be equal to minus Fk m times A. So this equation actually gives me Fk because I know m, I know A. So minus Fk is equal to m, which is 1.4 into minus 1.25. If you are worried about this minus, they will be cancelled, this minus and this minus. Okay, and Fk will be positive. So Fk or minus Fk is equal to minus 1.4 times 1.25 is 1.75 minus 1.75. This minus cancels with this minus if we divide by minus 1 both sides. So Fk is 1.75 Newton. Right? Now, where can I get Fn from? This is the first step. Second step, so along y, Fn is equal to Fg equal m times g. Here I use m times g because I have the mass. So it's equal to 1.4 times 9.8. So Fn is equal to 13.7 Newton. Don't forget the unit. You should never forget the unit. Okay, so now I have them both. I have Fk, I have Fn. I come back here. So mu k equal 1.75 divided by 14.72. Mu k is equal to 0.147. This is the answer. So here we should be careful for two things, or about two things. When it says slides, then the only force acting is the force of friction. And here, when it says the object is slowing down, then the object has a negative acceleration, minus 1.2. Okay? Example 4. A student attaches a rope to a 20 kilogram box. So this is mass. This is the mass of the box. 20 kilogram box of books. He pulls with a force of 90 Newton at an angle of 30 degrees with the horizontal. So the force now is not horizontally, it's at an angle, as you see here in the picture. This is the rope. Okay, just to change the color. Alright, so here the rope. So he is pulling with this force This is F. This force, according to the question, is 90 Newton. So F applied is equal to 90 Newton. But it makes an angle 30 degrees with the horizontal. So 30 degrees northeast. This angle here, this is the horizontal, this angle is 30 degrees. Okay. The coefficient of kinetic friction between the box and the sidewalk is 0.500. So mu k also is given 0.500. Find the acceleration of the box. I have to find A acceleration. Okay. Again, the first thing we have to do is the free body diagram. The free body diagram is here. This is the box of books. Okay. The forces acting are Fg. Okay. Fn. F friction. Kinetic friction. And this force, the applied force, which is at the 30 degrees with the horizontal. So it's not horizontal, it makes an angle of 30 degrees. So this is the first step, free body diagram. Second step is to apply Newton's second law, F net equal m times a. So this is the acceleration that I'm looking for. I have to use this equation to find the acceleration. Now, what is F net? So again, to remind you, sum of forces along x-axis. Let's say that the x-axis is along the direction of motion. This is the x-axis. So what are the forces acting along the x-axis? Here we have Fk. Okay. Fn and Fg are not along the x-axis, they are along the y. F applied, it's in between x and y. So shall we count it with the forces along x, or it's with the force along y? Here we have to use what we learned before about the components. F applied has to be broken into two components. When I break F applied into two components, I will have one along x, which will be counted with F net, and one component along y, it will be counted with the forces along y. Okay, so this F applied here, I have the Fx or F applied x, and let me here make this number. So here F applied y, and I should not forget Fn. This is y, and this is x. Okay, so F applied now, خلاص, we can forget about it. It has been replaced by F applied x and F applied y. So now instead of having 4 forces, I have 1, 2, 3, 4, 5 forces. Fk, F applied x, Fn, F applied y, Fg. Two of them are along x, three along y. Now, f net is the sum of force along x. I have f applied x minus fk is equal to f net. So f net here is f applied x minus fk is equal to m times a. So to find the acceleration, I need to know the mass, fk, and f applied x. Now, f applied x and f applied y, how can I find them? Yes, using the component equation, fx equal f cosine theta, fy equal f sine theta. So f applied x is equal to f applied times cosine theta. Theta here is 30, so it's 90 cosine 30. It's approximately 78 Newton. F applied y is f applied times sine theta, so 90 sine 30, 45. Okay. So now I have f applied, I have the mass. Now fk is not here. How can I find fk? Remember that I have this coefficient of friction, and I know that fk is equal to mu k times fn. So I know mu k. If I find fn, then I can find fk. Now how can I get fn? Fn has to be calculated from the y direction. Since there is no motion along the y, so the downward force or sum of forces that are downward equals sum of forces that are upward. Like we used to put Fg equal Fn, okay, before in the previous problems. But now I have a third force along the y. So I have to equate here the downward force equal the upward force, or sum of upward forces. This means that I have to say Fn plus F applied y is equal to Fg. Sum of forces upward equals sum of forces downward. Fg is known, I can find it. F applied y is there, so this is the so Fn is equal to Fg is n times g minus F applied. So it's 20 minus 9.8 minus 45. So 6 minus 45. So Fn is equal to 1, 5, 1. Okay? So I got this. I have given UK. Now I can find Fk. Fk equal to UK times Fn. UK is 0.500 into Fn. How much is Fn? 151. 0.5 times this is if we're taking half of this number. 150 is 75 and the one is 75. Here. Okay, are we done? No, still have to find acceleration. After finding Fk, I come back to this equation. F applied x, finally, final step comes. F applied x minus Fk equal m minus a. So everything is given here except for a. F applied x is how much? 78 minus 75.5 equal m. How much is the mass of the box? 20 kilograms. And acceleration. This minus this is 3.5 equal 20 times a. To find a, we divide both sides by 20 over 20 from b equal 20a over 20 over 20. First cancel. And the acceleration is equal to 3.5 divided by 20, 0.17. Unit for acceleration, meter per second. Okay, so yeah, I know it's kind of long. So many steps are done in this question, in this problem. The only thing that is different from the previous problems is that the F applied is at an angle with the horizontal. So this forced us to find components, x component and y component. Then from the components we found Fn, but Fn here in this case is not equal to Fg. This is very important. You have to keep in mind that okay, most of the cases Fn equal Fg, but in cases such as this one, Fn is not equal to Fg. It's Fn plus F applied y is equal to Fg. We found Fn. When I find Fn, or when I found Fn, I found Fk, because it's equal to mu k times Fn. Then now I know Fk and I know F applied x. I can get back to this equation to find the acceleration. So here F applied x minus Fk equal m times a. I found this, and I have the mass given, so acceleration is equal to 0.175 meter per second squared. I hope you got this well. We will practice this. We will practice on those problems more in class. Until next videos, study well, watch the videos, and goodbye.